Today's daily code problem of the day is Find Champion Part 2, number 2924. There are n teams numbered from 0 to n-1 in a tournament. Each team is also a node in a DAG. A DAG is a directed acyclic graph, which means it's a graph with no loops within it. So we're given an integer n and a 2D integer zero indexed integer array called edges, and that has a length of m representing our DAG, where edges of I is equal to the u value and the v value, which indicates that there is a directional edge from team u to team v in the graph. A directional edge from A to B in the graph means that team A is stronger than team B, and the team B is weaker than team A. So the u is going to be the stronger team, the v is going to be the weaker team. Team A will be the champion of the tournament if there is no team B that is stronger than team A. We want to return the team that will be the champion of the tournament if there is a unique champion, otherwise return -1. So we got to keep in mind that a DAG does not have a cycle in it, and a cycle is a series of nodes which loops back to a beginning. So let's go ahead and identify our approach. To solve this problem, we are going to focus on a key observation that a team can only be champion if no other team is stronger than it. This means that its in degree, the number of incoming edges, is 0. Simple enough, right? So here's our plan. We're going to track our in degrees. We're going to use an array to count how many edges point to each node. We'll then identify potential champions, whichever team has 0 candidates pointing towards them, and then we're going to check for uniqueness. If there's only one team, then that's the champion. Otherwise, we will return -1. So in example 1 here, we do have a DAG. Sorry, my pen's not working. There we go. So we do have a DAG here. In example 1, we see that 0 is our champion because nobody is pointing to 0. If 2 was pointing at 0 or 1 was pointing at 0, it would not be our champion. But because nobody's pointing at 0, this means that 0 is the strongest. Because 0 is stronger than team 1, and team 1 is stronger than team 2, but team 2 is not stronger than team 0. So team 0 is our champion. We could look down here. So 0 has nobody pointing towards it, and 1 also has nobody pointing towards it. For this, we're going to return -1 because we do not have a clear winner. So let's go ahead and jump into the code. It's pretty simple code. First thing we're going to do is set up an integer array. We can call it our in degree, which just counts the amount of nodes that point towards each team. So this array is going to count toward the amount of nodes that point towards each team. It's going to be of length n, same with our amount of teams. We're then going to store the in degree of each term. So we're going to go through each term in our edges, so each team, and we're going to get and count however many times each team is pointed at. So if a team is team of 1, meaning it's the v value, something is pointing at it. So we will increment the count of how many teams are pointing at it by 1. That is going to keep track of however many teams are pointing at each team. And next, all we have to do is simply find our champion. So our champ is going to start as -1 in the situation where there is more than one champion count. So we'll have an integer champ count. As long as champ count is only 1, we will return champ count. Otherwise, we're going to return -1 because we can't have more than one champion. So we're going to iterate through all the teams and find those who have an in degree of 0. So for each integer I is equal to 0, as long as I is less than n, I can increment. And if our in degree of I is equal to 0, meaning that no team is pointing at them, our champ count will increment, and our champ will be equal to I. Lastly, we can just return if our champ count is greater than 1, then we have to return -1, meaning we have more than one champion. Otherwise, we can return our champ. So that's it. If we run this, so this passes our test cases, and if we submit it, passes all solutions. So that's it. Thank you, and follow for more daily LeetCode solutions.